So the key challenge in applying AI to the study and prediction of protein folding is that we don't have experimental data that tell us how all proteins fold. So we can predict the folding, we understand the basic rules, but then we are still not good at understanding how different cellular environments or chemical environments created by the surrounding nature affect protein structure. And so the only way we'll be able to solve this is by acquiring more data, more experimental data, and having AI systems learn from those basic rules that we identify so that they can be better at predicting these basic rules that will eventually tell us how proteins are folded. AI can help us a lot in applying novel strategies for therapeutic intervention, in this case by giving us information about the three-dimensional structures of proteins, either in their normal functional state or in the abnormal pathological state that we think is associated with different diseases. So this is where artificial intelligence promises to deliver by opening a Pandora box with opportunities that we still cannot fully grasp at the moment, but by understanding protein structures, we hope that we'll be able to have better strategies for interfering with protein aggregation, which is one of the problems in many of these diseases.